According to the National Electrical Code, the sheath, also known as the jacket, of the service cable must be removed when it is installed inside a PVC conduit. This is stated in NEC section 334.10 A2, which states that Type SE cable installed in raceways or concealed locations shall have the outer jacket removed. NEC section 334.10 A1 states that Type SE cable shall be permitted to be installed without stripping the outer jacket. The outer sheath of the service cable provides protection against abrasion and moisture. However, when the cable is installed inside a conduit, the conduit itself provides this protection. Removing the sheath allows for better heat dissipation and reduces the risk of insulation damage due to compression. The length of the conduit does not affect the requirement to remove the sheath. However, the NEC does require that the service cable be supported at intervals not exceeding 10 feet, as per NEC section 334.30. This is especially important when using long conduits to prevent the cable from sagging and creating strain on the connections. Remove the sheath from both ends of the service cable where it enters and exits the conduit. Use an appropriate tool to strip the sheath cleanly without damaging the conductors. Secure the service cable within the conduit using cable ties or other approved methods. Ensure that the conduit is properly sealed to prevent moisture ingress. Firstly, familiarize yourself with the National Electrical Code, specifically Article 334, which covers Type SE service entrance cable. This article outlines the requirements for installation, including when and where the outer jacket must be removed. Secondly, understand the purpose of the outer jacket. It provides mechanical protection and resistance to environmental factors like moisture and sunlight. However, when the cable is run inside a conduit, the conduit provides these protections. Thirdly, consider heat dissipation. Cables generate heat when carrying current. Enclosing a cable with its jacket inside a conduit can impede heat dissipation, potentially leading to overheating and insulation damage. Removing the jacket allows for better heat transfer. Fourthly, be aware that NEC section 334.10 A2 specifically addresses the installation of Type SE cable in raceways or concealed locations, mandating the removal of the outer jacket. Fifthly, the length of the conduit run does not change the requirement to remove the jacket. Whether it's a short stub-up or a long run, the rule remains the same. Sixthly, pay attention to cable support. NEC section 334.30 requires service cables to be supported at intervals not exceeding 10 feet. This is crucial to prevent sagging and strain, especially in long conduit runs. Seventhly, use the correct tools for jacket removal. A cable stripper or knife can be used, but care must be taken not to damage the underlying conductors. Score the jacket carefully and then peel it away. Eighthly, after removing the jacket, inspect the conductors for any signs of damage. Nicks or cuts in the insulation can create potential fault points. Ninthly, when pulling the cable into the conduit, use a pulling lubricant to reduce friction. This will make the job easier and prevent damage to the insulation. Tenthly, seal the ends of the conduit to prevent moisture and debris from entering. This can be done with duct seal or other approved sealing compounds. Remember that local codes and regulations may vary, so always consult with your local electrical inspector to ensure compliance. The function of the conduit is to provide physical protection to the conductors from damage, abrasion, and environmental factors such as moisture and chemicals. It also offers a pathway for future cable upgrades or replacements. When the service cable is installed within a conduit, the conduit becomes the primary source of protection, making the outer sheath of the cable somewhat redundant in terms of physical protection. Removing the outer sheath is essential for proper heat management. Electrical cables generate heat as current flows through them due to the resistance of the conductors. This heat must be dissipated to prevent the cable insulation from overheating, which can lead to premature degradation, insulation failure, and potentially hazardous situations such as short circuits or fires. When a service cable with its outer sheath intact is installed inside a conduit, the sheath acts as an additional layer of insulation, trapping heat within the cable. This can significantly reduce the cable's ability to dissipate heat to the surrounding environment. By removing the outer sheath, the cable can more effectively transfer heat to the conduit, which in turn dissipates the heat to the surrounding air or building materials. This helps to keep the cable within its safe operating temperature range and prolongs its lifespan. The NEC mandates the removal of the outer sheath to ensure compliance with safety standards and to minimize the risk of overheating and insulation failure. While the length of the conduit run does not change the requirement to remove the sheath, it is important to consider the impact of conduit length on cable support. The NEC requires that service cables be supported at intervals not exceeding 10 feet, as outlined in NEC section 334.30. This requirement is particularly important when using long conduit runs, as the weight of the cable can cause it to sag and create strain on the connections at the service panel and meter. Proper cable support helps to distribute the weight of the cable evenly along the conduit run, preventing excessive strain and ensuring the long-term reliability of the electrical system. There are several approved methods for supporting service cables within conduits, including cable ties, straps, and clamps. The choice of support method will depend on the size and weight of the cable, as well as the type of conduit being used. It is important to select support materials that are compatible with the cable and conduit materials to prevent corrosion or other types of degradation. In addition to removing the outer sheath and providing adequate cable support, there are several other important considerations when installing service cables and conduits. Firstly, it is essential to use the correct size of conduit for the cable being installed. The conduit must be large enough to accommodate the cable without causing damage to the insulation. The NEC provides guidelines for conduit fill, which specifies the maximum allowable percentage of the conduit's cross-sectional area that can be occupied by conductors. Secondly, the conduit must be properly sealed to prevent moisture and debris from entering. Moisture can cause corrosion of the conductors and connections, while debris can obstruct the conduit and make it difficult to pull cables in the future. Sealing the conduit at both ends helps to protect the electrical system from environmental damage. Thirdly, the conduit must be properly grounded to provide a safe path for fault currents. Grounding helps to prevent electrical shock hazards and minimize the risk of equipment damage in the event of a fault. The NEC provides detailed requirements for grounding electrical systems, which must be followed to ensure safety and compliance. When removing the outer sheath of a service cable, it is important to use the correct tools and techniques to avoid damaging the underlying conductors. A cable stripper or knife can be used to carefully score the sheath without cutting into the insulation of the conductors. Once the sheath has been scored, it can be peeled away to expose the conductors. After removing the sheath, it is important to inspect the conductors for any signs of damage, such as nicks, cuts, or abrasions. Damaged conductors should be replaced to prevent electrical hazards. When pulling the service cable into the conduit, it is important to use a pulling lubricant to reduce friction and prevent damage to the insulation. The lubricant should be applied liberally to the cable as it is being pulled through the conduit. It is also important to avoid pulling the cable too hard, as this can stretch or damage the conductors. The service cable must be sized correctly for the electrical load it will be carrying. The NEC provides guidelines for determining the appropriate conductor size based on the amperage rating of the circuit and the type of insulation used. Using an undersized cable can lead to overheating and insulation failure, while using an oversized cable can be unnecessarily expensive. Overcurrent protection, such as circuit breakers or fuses, must be provided to protect the service cable from overload and short-circuit conditions. The overcurrent protection device must be sized appropriately for the cable's ampacity rating. The service cable must be properly connected to the service panel and meter. The connections must be clean, tight, and free of corrosion. Loose or corroded connections can cause overheating and voltage drop, which can lead to equipment malfunction and electrical hazards. All electrical work must be performed in accordance with the NEC and local electrical codes. It is important to obtain the necessary permits and inspections to ensure that the work is done safely and correctly. The NEC is a comprehensive set of standards and guidelines for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. Local electrical codes may also have additional requirements that must be followed. It is important to consult with a qualified electrician or electrical inspector if you have any questions about electrical installations. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire hazards. Always disconnect power to the circuit before working on electrical equipment. Use insulated tools and wear appropriate personal protective equipment such as gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Firstly, consider the type of service cable being used. Common types include SC cable, which stands for service entrance cable, and use cable, which stands for underground service entrance cable. The NEC has specific requirements for each type of cable. Secondly, identify the specific sections of the NEC that apply to service cable installations. These sections cover topics such as conductor sizing, overcurrent protection, grounding, and wiring methods. Thirdly, understand the ampacity of the service cable. Ampacity is the current carrying capacity of a conductor, and it must be sufficient to handle the electrical load of the service. Fourthly, ensure that the service cable is properly supported and secured. This prevents strain on the cable and ensures that it remains in place over time. Fifthly, use the correct fittings and connectors for the service cable. These fittings must be listed for use with the specific type of cable and conduit being used. Sixthly, properly terminate the service cable at the service panel and meter. These terminations must be clean, tight, and properly insulated. Seventhly, ground the service cable in accordance with the NEC requirements. Grounding provides a path for fault currents to flow back to the source, which helps to protect against electrical shock hazards. Eighthly, inspect the completed installation to ensure that it meets all applicable codes and standards. This inspection should include a visual inspection, as well as electrical testing to verify the integrity of the system. Ninthly, document the installation. This documentation should include the type and size of the service cable, the location of the service panel and meter, and any other relevant information. Tenthly, it is important to remember that electrical codes and standards can vary depending on the jurisdiction. Always consult with your local electrical inspector to ensure that your installation complies with all applicable requirements. For example, NEC Table 310.15. B16 provides ampacity ratings for conductors based on their size and insulation type. NEC Section 250 covers grounding and bonding requirements for electrical systems. NEC Section 310 covers conductor requirements for general wiring. Consider the specific application of the service cable. Is it being used for a residential service, a commercial service, or an industrial service? The NEC has different requirements for each type of service. Pay attention to the environmental conditions in which the service cable will be installed. Is it exposed to moisture, sunlight, or corrosive chemicals? These factors can affect the type of cable and conduit that should be used. When pulling service cable through conduit, use a pulling lubricant to reduce friction and prevent damage to the cable insulation. Avoid exceeding the maximum pulling tension recommended by the cable manufacturer. Ensure that the conduit is properly sized for the service cable being installed. The NEC provides guidelines for conduit fill, which specifies the maximum allowable number of conductors that can be installed in a conduit of a given size. Use a conduit bender to make smooth, gradual bends in the conduit. Avoid sharp bends, as these can damage the cable insulation. Support the conduit properly to prevent it from sagging or shifting. Use conduit hangers or straps to secure the conduit to the building structure. When making connections to the service panel and meter, use a torque wrench to tighten the terminals to the manufacturer's specified torque. This ensures a secure and reliable connection. Label all service cables and conductors clearly and accurately. This helps to prevent confusion and makes it easier to troubleshoot problems in the future. Keep a copy of the electrical permit and inspection report on file for future reference. This documentation can be helpful if you ever need to make changes to the electrical system or sell the property. and before starting any electrical work, always disconnect the power to the circuit being worked on. This helps to prevent electrical shock hazards.